Friends, now we are going to learn how to simulate the high pass filter. So this is the circuit of the second order high pass filter. I hope all of you know how to make this particular circuit. If you don't know, then see the video of low pass filter first. So just I am going to mark it here. So this is my input. So the net name. So my complete circuit is ready. Now we have to see the output. So first we are going to simulate, then analysis, AC analysis. Now here. So start frequency 1 Hz, stop frequency 10 megahertz. You can find gigahertz, then change it to 10 megahertz. Vertical scale decibel, number of points per decade 10. It means it says that in every decade we are taking 10 points. So in the lab we have taken 4 points. Here we can take 10 points. Now come to the output. So we want V out. So already V out is here. If you are not getting V out here, then V out will be here. So we are taking V out here. Then simulate. So see here. In the top of this particular graph shows the magnitude response. So at lower frequency, magnitude is decreasing. So less as frequency is increasing, you can see magnitude is increasing. So after some frequency, it becomes a constant. Again, after that, it starts to decrease. So in ideal high pass filter, once it has reached to the maximum value, it should be remain constant. But in practice, we are seeing that it is falling. And this particular thing is happening due to the op-amp. So op-amp is having some capacitance also. Due to this is going to fall. If in your circuit you don't have op-amp, then it will remain constant. So this is the maximum gain. Now we have to find the cutoff frequency. So I'm bringing the cursor here. So in case you are not finding cursor here, click here cursor here. So cursor will come here, will appear here. So this is the maximum. So you can see in this particular graph. See. So x1 and y1, this is for first cursor, and x2 y2 is for the second cursor. So what I am going to do it, I am bringing first cursor here, second cursor here. So this is the maximum gain around 6.264. You can see here 264 is a 3, 6.4. Okay, maximum gain comes to 6.6. Now I have to take 3 dB less from this, so I am changing this second cursor. So you can see x to y2 is changing, and dx dy is also changing. So first I have to check this value is in decibel or not. So access property is in decibel. Okay, now so I want y1 minus y2 should be 3, means dy equal to 3. You can find it here where it comes to 3 minus 3. It is somewhat here. So my cutoff frequency, this will indicate my cutoff frequency. So the value of x2 will give me the cutoff frequency of this particular response. This is the cutoff frequency. And in the graph, normally we are drawing the 3 dB less line, and then we are cutting this. The similar thing we are doing here. And this is the phase graph. So this is the frequency response of the high pass filter. You can see it looks like a band pass, but this particular thing is due to the op-amp, and it occurs at the very high frequency. So this is the called frequency analysis, या AC response of the high pass filter, what we have drawn it. Thank you. Now you have seen this. This is the transient. sorry, AC analysis, you can also see in the time domain, means transient. So when I am going to give the frequency of 100 hertz, my output will be smaller than the input. I will show you, and after 10K it will remain constant. So let us see here. Now I want to do, so what I am going to do, I am going to take a here oscilloscope. So this is the oscilloscope. I am connecting here positive. I am taking one ground here to connect it. So on channel A we are taking the output, in channel B we are taking the input. Now I am going to reduce the frequency. Suppose frequency I am going to take 100 hertz. This is the 100 hertz. Now click on this. Change the scale. This is the A. A corresponds to the output, B corresponds to the input. You can see it is very small. But as I am going to increase the frequency, you will find the frequency is increasing, output voltage is increasing. Now I am making it to 1 kilohertz, 10 kilohertz. Okay, it was running. Let me stop this. Again we have to send it this. Now frequency I have increased, so you can see. So channel 1 was, channel A was for the output, so I am increasing it. You can see. You can see. So my output has been increased drastically. So this we are verifying onto the oscilloscope. That was the onto the AC analysis. Thank you.